other end.
Okay.
Cool. How are things with you?
Good. Busy.
Yeah.
We got fieldwork coming up, and it's been a bit chaos.
Oh, where are you headed?
Northeastern Oregon,
Okay.
kind of near Walla Walla. You know where that is? Yeah.
Cool.
Is it like getting the empty data?
Yeah. So we'll be collecting probably around 80 sites or so up there.
Oh, wow.
Yeah. Yeah, so I don't know like what agenda items you have today. I thought it would just be worthwhile to maybe chat a little bit about the issues that we posted and sort of see if we can make sure we're on the same page and then come up with some next steps, and also maybe get a feel for who wants to be involved. I know you've sort of sent a number of names on Slack, and yeah, so just kind of get a feel for the lay of the land.
Sure.
Cool. Okay. I'll maybe share my screen here. I'll get the issues up. Sure, I'm capturing that. Can you see that?
Yeah.
The infinite loop.
Yeah.
Cool. Okay. So I was chatting with Rowan a bit about this last night, and just sort of this sketch. So like, I guess the couple key things I saw here were to always be able to access the source data and then your current data, which is like whatever processing steps you've applied. So we can always sort of have a look at like the impact of what you've done.
Yeah. So that's definitely a good idea. A lot of times you do stuff and it's wrong.
Yeah, so I guess like always being able to query that, and we can be clever about how to actually do that as well. I mean, because you probably don't actually want both always sitting in memory, but we can figure that out as we go.
Yeah. And as far
Yeah.
as
Go ahead.
as far as databasing goes, I don't know. It seems like the number one would be Pandas. That seems to be pretty compatible with most things, and growing as well.
Yeah, and then it also seems like things like Dask data frames and stuff like that are sort of have a similar interface to Pandas.
Yeah, it seems like this is an underlying theme for a lot of advanced stuff.
Yeah, and this actually, so this sort of line of conversation led Rowan and I to chat a little further about what these classes look like. And in a lot of ways, I think we actually want to keep the data and the processing steps separate. So in the sketch that I have here, we actually have the data attached to the time series, and like in the sense of processing steps, and then we have methods there as well. And I think actually we want to keep those things separate. And why we might want to do that is because depending on like how data is coming in, how large data sets are and things like that, we can be smart about things on like the interface side. So if Pandas makes sense, we can use Pandas and access it through a common interface. But we could actually basically swap out Pandas for something else. Sorry, Dom's on. We can swap Pandas out for something else if there is something more suitable.
Right.
So if we need to be working with Dask, or if we want to interface to HDF5 or whatever, as long as we clearly define the interface, then we can sort of use whatever database makes sense.
Yeah.
Cool. Okay. And then the processing steps in a lot of ways. Have you seen the SIMPEG mappings? No. So, I mean, basically all they are is like you have so in the SIMPEG case, you have a model and we want to translate that somehow to physical properties on a mesh. So in the simplest case, like when you're inverting for conductivity, you're actually generally inverting for log conductivity. Mm-hmm. And then we take the exponential and that gets you then to the physical property. And so the way we treat that is basically like a matrix operation. So even if it's not, you can still always basically say my mapping times my model, and you get out your mapped model.
Right.
And so in a lot of ways, the processing could be quite similar to that because you have now your data. We're just going to apply a step, and you get your process data out.
Yep, that makes sense.
Okay. So then each like processing step is potentially just a very small class.
Yeah.
Okay. Yeah, and then I don't think there's any problem to basically then creating a pipeline. So all of that is you're just stringing together a bunch of these processing steps. So that would be similar to then like what we have as a combo map in SIMPEG. So all that is like you basically, if we're inverting again, we'll do conductivity. You generally don't include air cells. So maybe the first step is you include your air cells back, take the exponential, and now that's your physical property model. So that's two mappings, but we can treat it as one operation. Does that make sense?
Yeah, that makes good sense.
Okay.
Because a lot of the times you want to try a whole bunch of different things, and it'd be good if you could just do them separately.
Yeah, and doing them separately. And then basically, once it's all strung together, as long as we make sure that it's serializable, so we can write it out to a probably JSON or something simple, yep. All the parameters and the order of operations, then you can always load that back up and sort of save that processing pipeline. Sorry. Okay. Oh yeah, I started. Yeah, so do you think that like mode of working makes sense?
Yeah, definitely. Nice and modular. Because I'm sure a lot of people will probably want to build their own classes, maybe some weird filtering technique that no one's heard of.
Yeah.
And they can easily just plug that in. Just as long as they know the inputs and the outputs.
Mm-hmm.
So, yeah. I guess if we find some sort of standard format, I think that's relatively easy.
Yeah, and I think, have you seen the properties library?
In SIMPEG?
SIMPEG relies on it,
okay.
But it's actually out of 3 points. So I will send you this. And so this is actually, I think, a very good way to build up the classes, because then we make sure that everything is serializable. So basically, like what it is it's a more declarative way to build your classes. So all of the properties and like inputs when you instantiate a processing step, we're just very clear about like what you expect to be coming in. So if you expect an integer value coming in, like we can go in, validate that, make sure that we're getting what we're expecting, and then that all saves nicely as well.
Right. Okay. Cool.
Okay. So I guess like in the thing that I'm wondering if this is the next step is to basically like maybe take a small data set. First of all, make sure we can get that loaded in, and then apply one processing step. And we can sort of sketch out like what that looks like.
That sounds good.
Sure. Yeah. So I can send or maybe put somewhere just some ASCII files of time series.
Okay.
Maybe just like a 4-hour block or something. We could figure out a way to get that into a nice format, and then do a simple process like maybe a notch filter or something.
Yeah, that would be good. And how large of a file would 4 hours of data be?
So in let's see, in ASCII format.
I guess like once you've loaded it up.
Yeah, well, like we could just do NumPy or whatever.
Yeah.
Like that's fine if it's too big, or even like HDF5.
Right.
Just number as well. Like that's at this point, like that's fine.
Yeah. Yeah.
Let's see.
Or like all I was thinking is grabbing a subset, or like just because for the first shot through, I don't think we want to deal with the problem of larger than memory data.
Yeah. So 4-hour blocks would be about 80 megabytes.
That's
okay.
fine.
Yeah.
Per file. So, you know.
In ASCII format?
In ASCII format. So it can be definitely crunched down to something smaller.
Okay. That should be fine.
And that's like it's a one component, or like it's a multiple component?
So I'll send files for 4 different channels. So the 2 E's and 2 H's.
Okay.
And so total it would be what, 300 megabytes or something.
Yeah.
Okay.
And we're gonna use Pandas as a first shot. Is that the idea?
I mean, we can start with NumPy arrays, and then that's pretty transferable to Pandas, I think.
Yeah.
Yeah.
Yeah, I think that could be good because NumPy like is first of all the simplest format we can deal with, and then building complexity from that
Right.
might be easier,
Yeah.
and a little like maybe more transparent of what we need to do.
Okay. Yep. So NumPy. Okay.
Yeah, so like the steps, we just want to get the data in, plotted, and then perform a single, like a notch filter.
Yeah.
Okay. What would be the easiest way to share? I guess we could even put the files in GitHub for now, as just like start an assets folder. We can just have them in there, and then later on potentially remove them or use them for testing or something like that.
Yeah, sure.
That sounds. Yeah, because then we keep track of if we change it or anything like that by accident. Cool. Okay. And then, yeah, with other people that you're in touch with, who do you sort of see being involved and like interested in certain areas? And
yeah, so I talked to, I guess you probably know Carl Kapler.
I don't know if I've met him, but I do know of him.
Okay. Also known as Crazy Carl.
But I don't think I've met him.
Good crazy, but so he's worked a lot with Gary's code.
Okay.
Translated apparently a lot of it into Python, but he did it while he was working at a private company, so he's not sure what the rights on that are. But he'd like to be involved. Right now he's pretty busy with work, but he'd like to at least maybe be like someone to talk to about how to do things or go a certain direction.
Yep.
And if he has time and also money, then we could maybe bring him on.
It's always a problem.
Yeah, because he's a private contractor, and that's similar with David Meyer as well. I think he'd like to be involved, but I think that his time is, I don't know, his money.
Yes.
So I'm not sure how much he actually wants to be involved, but it seems like he's been making comments and stuff, so that's been good.
Yeah.
And then Ben, I sent him his email yesterday. He's a student with Gary. He's been working with Gary's codes, so he knows him pretty well.
Okay.
And he's just a grad student, so I think he would be probably a good person to bring on. He'd be more than willing to spend time on it, I think.
Cool.
Lou, I think, is just an umbrella. I think she can liaison well with industry.
Mm-hmm.
So, do you know Scott Urquhart at Zong?
Yep.
So he has been kind of pushing someone to build a new processing code for a long time.
Okay.
I haven't talked to him about this, but I think we could bring him on board, and I'm not sure whether he'd financially support any type of product. I don't know. We'd have to work out the agreement there.
Yeah.
But he's more than willing for open source stuff, which is good.
That's great. Yeah, I mean, I think right now we're probably still too early to look at any sort of financial.
Yeah, for sure.
But it's absolutely good to keep in mind and keep it on the radar, because if there is somebody down the road, especially if there's somebody consulting and interested in contributing time, and that would be a way to do it, that's awesome.
Yeah, for sure. So there's Scott and Nate Lindsay. He's a grad student at Berkeley.
Okay.
He's been doing some Python coding. He'd be interested, I think, and maybe kind of just doing a little bit more.
Who does he work with at Berkeley?
He kind of went to the dark side and started doing seismic stuff.
Okay.
But he works with Greg Newman at Berkeley National Labs.
Okay.
Yeah. So, and I guess Paul Bedrosian as well here at the USGS.
Right.
He probably doesn't have time to code, but he'd be a good person to talk to about where to go with things. He's worked a lot with Gary's code and knows how crappy it can be to get around stuff. So,
right.
Yeah.
Okay, cool.
And then down the pipeline, so if we do get this going in some large capacity, there's also funding sources through the USGS for innovation funds.
Okay.
Which is specifically designed for code development.
Oh, good.
So that's just maybe an incentive.
Wow. Yeah, that's good to know.
But So I guess once things do kind of progress and we have some sort of data format from time series to go into the Fourier domain, we might be able to split up kind of the tasks a little bit more towards people that have expertise in different areas.
Yeah, absolutely. Especially like once the structure's there, and we have a bit of a game plan, that makes it a lot easier to bring people on.
Yeah, for sure.
Cool. So one of the other things that I think would be worth sort of sketching out, and we can even do this like in a Google Doc or whatever is easiest, is kind of scoping out the library, like in terms of, you can check out the README. There's like a couple points that I put down just to state like what it's going to be, but it would be great to sort of flesh that out a little more and get everybody's input on what this is and where we're going, and just kind of getting a bit of that mission statement and communication piece together.
Sure. Yeah, that's a good idea.
Is it Google Doc the easiest way? Does that work with you?
Yeah, just as long as it's not spam or whatever's going
right. Whatever's going around. Yeah. You know what? I think I actually got one of those phishing emails, and it looked like it was from Paul.
Oh, really?
Yeah. It went to my spam folder, but yeah, I was surprised to see an email from him.
Yeah. So how much time and effort do you think you guys would like to put in?
Like I'm happy to be involved on a regular basis. I can't say that I'll be spending like days coding, but like early on getting things set up, I'm very happy to be involved quite regularly.
Yeah, me too. Yeah, I'm not like not very interested in structures, but I'd be really interested in the actual contents and developing the pieces inside of the processing. So, and I have a couple people connected to in India, so yeah, they probably want to involve here, and then they just started the PhD, so
right.
they want to spend a lot of time, but I'm not sure where they are now. But
okay, cool. I mean, I'm in the same boat. Like, I can't just spend days coding, but I can help try to push things along.
Okay, that sounds good. Maybe what I'll do too. So we have the Slack. I think it would be good, and I'll maybe post a note and get some input before doing this, because there's a ton of channels right now, and some of them aren't all that well used.
Yeah.
But I think actually it would be worth having a specific processing channel, and then we can direct all questions and sort of development and ideas from this there.
Okay.
So I will do that, and feel free to invite anybody that you think would be interested to that. It's just through slack.simpeg.xyz they can join. So.
Okay. Cool.
So in terms of like, so we're going to set up this data, and we're going to do this notch filtering things. Like, are we going to put some Python code up in the GitHub, or what's?
Yeah.
Like, is that the idea? What's? Okay.
Yeah. So I think like if you could start an assets folder and then put the ASCII files in there, and then what we can do is based on that, I'm happy to start sort of the boilerplate stuff and getting like the bones of the library in there.
Okay.
And then, so the first step there will just be like setting up the folders and init files and stuff like that, and then also docs and testing.
Okay.
And then from there, try and sketch out like I don't know, a first load in and plot of the data, and that'll be a bit of a starting point.
Yeah, right. That's another thing, is plotting time series is pretty awful.
Yeah.
If it's like 2 days of data,
Yeah.
not a good way to
Right.
plot things.
I think probably like those things we can just like use OpsPy, or like they do deal with a pretty big data set, like the size big data.
Okay.
But for a long time span.
Yeah.
There might be.
So they use mini seed format usually. It's kind of their go-to.
Which format?
It's called mini seed.
Okay.
It's basically the seismic standard for time.
Oh, okay.
So that could also be another avenue.
Let's see.
How to deal with mini seed format.
Okay.
Cool.
That's good.
Yeah, and then once we sort of are looking to some of those things, we can get in touch with ObsPy and potentially some of the seismic crowd, but I think probably having a few things in there and a better sketch of what we're up to would be good.
Yeah, for sure. Cool.
Yeah. Any other things on your list that you want to go over?
Yeah, no, I think that's all good.
Okay.
I think that's a good start. Just building the foundation turns out to be difficult.
Yeah. Yeah.
But that's the hard part.
Yeah, once that's built, then it's pretty easy going.
Yeah. Yeah, getting the infrastructure in place. Cool. This will be exciting.
Yeah. Oh, so you said Python 3 we should start with?
Yeah.
Okay, we'll have to load that on my computer then.
It won't preclude the use of 2.7. I'll still probably, like right now, I'm still on 2.7,
Yeah.
but like making sure that everything I write is 3 compatible. So like you don't actually have to move to 3 right away. But yeah, down the road, there's a lot that they've improved, so it would be get on there.
Yeah, it's better to do it now than later.
Yeah. Yeah.
Okay.
Cool. And for the notch filter code, do you have an example of what those steps are, or like if you have some code that does that?
Yeah, I have some code that does it.
Okay.
Oh, nice.
And it just basically runs on NumPy.
Okay.
Oh,
And
nice.
where is that? Is it on GitHub?
Yeah, it's in MTPy.
Okay, cool.
It's under something. It's under processing, I think.
Processing.
Probably filter.
Yeah.
Okay. So is it adaptive notch filter?
Yep, that's it.
Okay, cool.
Sounds good. So how are we making like so there's an MTPy
Mm-hmm.
and like it does its own functions, but like how is how are we kind of like what is the difference between like what we're doing here in MTPy? What's our sort of like, because yeah, we need some sort of identity here, I guess. Like, yeah, not exactly sure what was the sort of like the scope of the MTPy.
Yeah, I mean, I would probably start a new kind of just processing module. I think that would be probably
Okay.
good, and maybe down the road if it's maybe incorporate that into MTPy or vice versa. I don't know.
Okay.
Because right now MTPy is like it's a pretty hacked together module that doesn't follow PEP 8. There's no tests or anything.
Oh, I see.
Because it was just me being science writer and use it for functionality as opposed to whatever. So starting new, I think, would probably be the best option.
Okay.
And then if you want to pull things from MTPy, that would be pretty easy, I think.
Cool.
Because like down the road, building EDI files or some sort of MT response file, that's all already done.
Cool.
So, yeah, it's just getting from time series to responses that's new.
All right.
So I guess we could also come up with a fancy name for this.
We could, yeah.
Some sort of acronym that makes no sense.
Yeah, a unique. We can put that in a Google Doc or start an issue, and
Yeah.
we need a name and a logo. So.
MT Pro or something.
Yeah.
Down the road, can you also provide the reference empty station data as well? Like this is one station, right? Like and
Yeah.
like down the road, not now, but like down the road, can you provide that data?
Yeah. Yeah, I've got plenty of data.
Perfect. Cool. That sounds great. Yeah. Well, yeah. I'll try to play with it, like what you provide, and then also your notch filter function, and see if I can an example.
Sure.
Okay. Cool. I'll try to put that up by today.
Okay. Well, that sounds good. And we can be in touch and maybe briefly touch base even next week or, yeah, go from there.
Sure. I'll be out in the field for a month or so.
Okay.
From like June 15th till the end of next week, till the middle of June, pretty much.
Okay.
Sounds good.
Sounds good. Cool.
Right on.
All right. Well, thanks, Jared.
Yeah. Thank you, guys. That's great.
All right. Well, have a good afternoon.
Yeah, you too.
See ya.
See ya.